get one from Marcus.
Oh, good.
Is he coming or like?
I have no idea. But if you take one for him, that'd
I
be
know,
nice.
but he's not athletic there.
And who else is missing? Is anybody in Sienna's house? No? Okay.
Wait, we're done. See? You?
Almost.
Okay. Wait, so what's this then?
I'm just getting that out in prep.
Wait, is Dion a unit?
Nope. D's the next one. We are actually we are done C. Because all the ones that were not done, we've done. I don't know if that makes sense. But in doing all the other things, we end up having to do the things we are about to do. I don't know if that makes sense. But skill test, this reminds me of your attendant, so I can ask a skill testing question. Elena?
I just have a quick question on how the test works. Like, say,
See me after? And then I can. Wrong class. You are not science 10. Marcus isn't here. Sienna isn't here. Is anybody else not here? Please speak out. And Mark, Naomi, gone. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Okay. Which one of those gives you the uncatalyzed exothermic reaction in the forward direction? 1, 2, 3, or 4. And I'm going to ask Hannah. 1? 1? Uncatalyzed. So we're looking for the highest peak. Yep. And we're looking for exothermic, so it has to go like this. There. So 1. Perfect. So the catalyzed endothermic in the reverse direction. So cat, endo, reverse. Don't call out. And Portia. Which one of those peaks represents the catalyzed endothermic reaction in the reverse direction? 2. Goes like this. So it's catalyzed. We're going reverse. And in the reverse direction, that in fact is endothermic. It is too. Uncatalyzed endothermic in the forward direction. Elena.
Exothermic still?
Endothermic uncatalyzed forward direction. 3. Okay. So a little bit of a brain warm up. And identify the reaction product, intermediate, and catalyst from any given reaction mechanism. When I say we've already done this, this is what I mean. This is identifying everything that we already did in, don't move that around, Mr. McCall. When we did this, we identified the reaction intermediates, we identified the catalyst, we got the overall reaction. We had to do it to do this particular know and be able to learn. And then there's a whole separate learning outcome on it. So I'm going to give you a reaction. I want you to identify the reaction intermediates, the catalyst, and the overall reaction. I don't need to draw a little circle around that. This is where of course Mr. Phil. This is a vitally important reaction across industry. So, there's the reaction mechanism. It takes place in 2 steps. Identify the reaction intermediates, identify the catalyst, and put the overall reaction down below. Okay. Who needs points? B. Dealer's choice. Identify a catalyst, identify an intermediate, or give me the overall reaction.
The intermediate is CH3, CH2 plus.
CH3, CH2O?
No, CH2 plus.
Oh, there we go.
That one, that's the start, and then at the beginning of the next reaction, yeah.
Excellent. That's a reaction intermediate. Who else needs some points? Naomi. Having just jumped in, you can either identify a catalyst or give the overall reaction. Or I can help. Ask a friend.
Yeah, I just got here. Can I answer?
Yeah, no, you did. Is there anything that is on this side that is repeated on this side? H plus. And you notice there is one of the key differences between it is instead of being made and then used up, it appears as if from nowhere and then and is used up and then is pulled back out again. What is that? Catalyst. H plus is a very common catalyst for a lot of reactions. And Karis?
Wait, but isn't H like used to make the intermediates, so wouldn't it not be a catalyst?
The definition of a catalyst is not used up. So it's used, but it's not used up. So it pops out again at the end. So it did take part of the reaction in some kind of way. But since we get it back again, it's considered a catalyst. Overall reaction or identify a different reaction intermediate or catalyst? Did I add something you didn't say?
Yeah, I think you added the CH3.
Oh, I did.
You did.
I just started writing what I thought you were saying, and then I just added the other thing, which is entirely wrong, given that two things get erased. And luckily, what I can do is I can just say that never happened. Perfect. And that's how you add an alcohol group to an organic compound. Find an organic compound that has a double bond where you want a alcohol group, react it with water and acid, and you'll end up making an alcohol out of it. And that alcohol is, that's drinking alcohol, that's ethanol, 2 carbons and an OH. There are thousands of different alcohols. Do not drink alcohol from the lab, because if it's methanol, it'll turn you blind and possibly also kill you. And if it's propanol, it'll do the same thing, just slower. And so there's lots of really poisonous alcohol. We did once have a person who stole alcohol from the lab, and they stole methanol, wood alcohol, that would poison them. We had to have a whole assembly with the entire school to tell them, please don't drink that. You will die. Steal from your parents' alcohol cupboard instead. If you're going to steal. We're not telling you to steal, just that's safer. Do the same for this one. Does anybody need me to go back? Did I do that too quick? Oops, okay. Did you do that? What?
Not do it?
No, you're on the right page. When you flip, I thought you were on the wrong page. Run the old ones. You've done the same thing. Did you just realize? We're sorry. I handed that out so we're ready to go with the new ones, and I didn't forget. It's not actually on there. There you go. You have the old ones? Do you want to get them out? Ready to go? Practice. Because don't forget, if it's too easy, I'll register you in an AP behind your back. Whoa. Okay, we'll do the same thing. And this time I'll do it by color, red or blue, and if you're colorblind, circles or squares. Matt Wood. Either one.
Me?
Yeah,
Um,
give me one of them.
the PT is the catalyst.
PT is the catalyst. Oops, wrong color. Already messed up. So I don't need to worry about that one. Reaction intermediate, B.
PTC2H2.
Yeah. Are there any more, or do we go to the final reaction, please? Karis again. PT. C2. So that one's that one. And is there another one where we go to the final reaction, please? Coal. Go to the final. So what's the final? Oh, did you forget? Sorry, louder.
The H plus H plus the C2H2.
Hold it. I can't quit. Plus. This just needs a correction.
I think there's another H.
You just said H, so I was being funny by not putting the 2. And because you have 2 of them, you add them together. This is just like adding algebraic equations. You cross out what occurs on both sides. You add together what is on the same side. H2 goes to C2, H2 goes to C2, H6. That is a triple bond that is being removed and turned into a double bond over hydrogen. Good. Excellent. We're done C. So ABC is page 1 to 36, questions 1 to 63. I have. Oh, did we? Oh, no, we did turn it on. Excellent. So, is one of these the. Okay, so your quiz is on Saturday. It's only on C, unless you annoy me enough to make it worth on 1-on-1. That's October 5th. We have our first test, ABC, on the Wednesday before the break. If you are an extra time candidate or you just want extra time, arrive 10 minutes before class starts in the break in between on a Wednesday. So instead of starting at 10:55, you can start at 10:45. That is 10 minutes after your previous class. And that way you get a little extra time because we're in the middle block on that day. Does that make sense? Not just make sure that if you need a little bit more, I still build in, with that I build in 50% extra time into that period. If you're an extra time candidate that requires 100% extra time on your IEP, let me know, because then you have to go into the testing center in order to make sure you can have that full and complete time. Yes?
Do we get the whole block to do it?
Yes. Yeah. I wouldn't. We're going to write a test at the end of class. That would, I think I would be shot, probably rightfully so, if that's the case. And that's the Wednesday before break, just in terms of timing next week. Now, I take your Hebden in on that day because you don't need it to study, because theoretically you should be up to date at that point. So I will physically have it. And that's when I go through in detail and look that have you done all the questions? Are you doing extra questions and do it in more detail? The ones where I've been taking pictures, I'm going to give you feedback very soon. I haven't quite done it yet. But I evaluate it on something that looks like this. It's slightly different. But I don't have it posted yet because I don't have it for feedback. But I just take a look at the pictures that you had ready on quiz day. Do you have any notes or reflections? Is it marked? Did you have it ready to go? Was it on time? You were all up to date. And these go to learning skills. They're not worth marks. It's not the Hebden mark either. This is just learning skills. Are you up to date? Are you on time? So that I have something to base that on. Sorry, I keep saying learning skills. It is now called approaches to learning. They used to call it effort rating because it was your effort in class to learn. Then they called it learning skills because they felt it is your skill at learning. And then they said, no, it's how you approach your learning. And I can hardly wait to see what they're going to call it in 2 years' time. They literally change the date every 3 to 4 years because they get bored. Is there anybody new to this group? Ah, excellent. So, did any of your classes show you that? Approaches to learning? Because they forget to in grade 12. So you're going to be evaluated on 4 separate things: your time, your focus, your duty, and your engagement. There's a whole sentences that refers to each of them. I go by those one words because I think it summarizes it. So, is your coming to class prepared and on time? Do you meet your assignment and assessment deadlines? Do you have an effective system for your notes and handouts? Do you stay on task? Do you respond to questions? Are you listening actively? Are you a positive impact on your peers? Do you come for extra help? Do extra work? Do you write using the new words you have learned? Do you set short and long-term goals? And we evaluate it on a habitually, often, occasionally, and rarely. And so habitually, every single time, often, most of the time. Most advisors only care if it's one of those two. And if it's not one of those two, then there's some kind of problem. I hear that some people make your ability to have a console in your room dependent on those. Don't tell me that, because that is a bad reason for me giving you a habitually. The good reason is that you're doing it habitually. The last one contributes positively to the learning environment. Some people believe that means I put up my hand all the time in class. That is not what it means, or at least not in my class. That means that you are taking an active part, and that if you're working at the board, there's a discussion around you, you're taking part in that. You don't have to be an extrovert that puts up their hand every 3 seconds to get that. I never put up my hand in school because I didn't want to. But if you're taking part in other ways, that can be perfectly fine as well. Yes?
Do you get like marks? Like, you know, like midterms, do you get marks? Like,
So your next mark will be approaching the 20th, and it's only ATLs.
so
There's
yeah.
no actual marks in it. And the reason for that is that you shouldn't focus on your marks. You should focus on how you learn. And if you focus on how you learn, then the marks will come. Because, of course, marks aren't important right now, right? Right. Obviously, they're hugely important, especially at this level. But you will have marks. But right now, you have like 2 quizzes. That is statistically not enough to go by to give you a real mark, actually. If we were in June and I took those 2 quizzes, and let's say they didn't count, and let's say you did awful, and I put them back in, your mark wouldn't change. Because you will have done so much by then that all of that would just be your average. So the only thing that matters is what do you do over time? What resting point do you get to? And so what is the average? So it counts for way too much right now just because it's only 2 things.
Okay. When are the marks? When do marks go in?
Well, your first real mark is actually the first test next Wednesday. I don't know when they're actually due.
Like for report cards?
Yeah, I don't know. I usually wait until someone starts yelling at me to put them in. Yes?
For our lab, like,
Those books that are sitting right over there? Yes.
yeah, when do we get those, like, graded
Soon.
and stuff? Okay. I was just wondering.
I got the quiz done, but I didn't get the lab. They stare at me every day. I'm guilty. And then I got your quiz done. I didn't get to them. I was supposed to get them to this morning. Then there was a leave emergency, and so I didn't get to them. But I am planning to get to them today because you're doing a lab next week,
Okay.
so you have to have them back next week, and we're doing lab safety.
Okay.
Any other questions? Excellent. Given that we are done ABC, I'm not going to take the whole block off right now. But if you would like to take 20 minutes right now, get out your Hebden, start a few questions, ask me something, sort out your life in terms of studies. Yes? Pardon? Yes? The test. If your quizzes are higher than your test, they just count. Now, they don't count for quite as much, in that there will be more quizzes. They're each, no matter what they're out of, I make them count as 10, so that, because no one area should be necessarily as equal as another. And so some of them are over 800. And then they just add up. And they don't go into test marks, they go into homework. So stay in the bucket that your lab does. That being said, that's what traditional non-traditional worksheets. They're divided out into your communications
No, I
and
think you
your
should
critical analysis
I
quizzes.
don't think
And your lab one, if there's any quiz that are like this, attendance reserve that. And then they go into a bulk, and they go separate.
Plus, I just really focus on the ages
Oh, they have-
test.
Can you please show me?
Oh, come with me.
They keep getting mad at us for
Also,
saying
about, I have volleyball Friday and Saturday. So I don't know that Thursday I would be ready to the test. Can I just like take it Saturday? We also
Our test is set. Quiz is set. Oh, it'll depend on what you do.
Or would it be possible to like set it up in the library with the?
They don't do that anymore. No, yeah, there's nobody there. But let's first do this. So you had, I think, compared to last time, numerous units. And this part is that you took. Well, you took.
that have been with you.
Because I work better.
Oh, you can do that. But what you can't do is stoic with
It
grams.
was really sad because I wanted to practice actually like
It is math. You can't do stoic with math. You could only do stoic with number of atoms, which means it works with moles, works with the number of atoms, and because gas's volume is proportional to the number of atoms, it works with gas volume. You don't even need the number. If you always go to moles, it will always work. But mass doesn't work because the atom's way different than mass. Like an oxygen 16 times heavier than hydrogen. So you do the ratio, it comes up completely wrong. You have to work with the number of things. So you can use the table, but when you used the table last year,
Oh, it's really yellow. Yeah, those are not forever.
would you have to? Yeah, I guarantee you would have done it. Now, I think he sets it up here. So what's the top?
I mean math.
Mass. Or mass. And I think he does that so you divide one way and multiply another. Do you know that n means moles? Okay. N is meters. I think you use it. That means moles. N means moles. M means meters or mass. And M means molar. Now, if you put in 125.0, let's say here, grams, and this is 2, 3, let's say it's just like this.
Page 34.
You cannot go from here, you can't multiply by 2.
Question 56 to 61.
What you have to do is go through the molar mass, get the moles, and then go over wherever you need to go, and then go back up to the mass.
I think I did that on the first question, and then here
They don't actually take it.
Okay.
like this.
It looked like you did it, where's the 62.20? No, you did
Because I
that.
did it from the math.
You
Like,
did,
here I did
you
that.
got the molar mass, you did number ratio, you also got that, but the other part is this mass was the total amount of calcium carbonate that you had, but not all of it was used up. So it's the excess rate. So you couldn't use it to figure it out, what you had to use was the rate. You know that was the reaction consumed HCl at an average rate of 2 moles per minute for 10 minutes. So here HCl, 0.200 moles per minute, right? Then if this is not the moles, this is the rate. There's a couple of ways you can use it. The table, because this is a mole, which is number of atoms, you can add rate. And then you could have gone in and gone like 0.200 moles per minute and gone CaCO3, HCl, this part doesn't matter. You could have just gone, oh, times 2, hold it. It was HCl, 0.200 moles per minute. I gotta give you that. If you want to go from here to here, you just divide by 2, multiply 1, and this is going to be used up at 0.100
No, but, oh, sorry, EAR. EAR is
So you can use, yeah, you can use stoichiometry on rate as long as it's moles. It can only rate, stoichiometry can only be used with moles. Oh, it has to do with rate.
Well, yeah, but it's in calories.
Did you read these?
Yeah.
Oh, chlorine present was a resolution. This reaction. No. This will answer. If you have a lot of chlorine there, yeah, what's that what is it getting rid of? I will answer in a second. What's that? Which is also known as the protective layer that protects us against the sun rays. That's ozone. Chlorine, like it says in there, is destroying the ozone layer. Yeah. So divide by 2, multiply by 1, you get this.
So is that
Yeah.
well, where's the 10 minutes?
Well, you haven't done it yet. So you need the number of moles, right? Because you have 125 grams total. How much did you use up? Well, the moles of CaCO3, you can do rate. Moles per, I wish I could just grab this and do it over because I'm running out of room. But how do you take a rate and just turn it into moles? What would I have to multiply that by? 10 minutes. Because it's over 1 minute, so you can just cross out minutes. And then you would have gotten 1.00 moles. And then if you took mass, CaCO3, you would have 1.00 moles times, I think it was 100.1 grams per mole. And you basically get 100 grams. And then 125 minus 100 grams. Oh, that's the molar mass. You calculated that right there.
Okay.
121.
That's
Yep.
your answer.
Yep.
100 grams.
Yeah. So the error here is that you were solving it, I think, in sort of a like Chem 11, I'm going to use the table and get the answer. But this question was about rate, and you had to use the rate to get the number of moles. But you did need the Chem 11 stoic to, because you also could have done, oh, it's 0.200 moles per minute of HCl. Is that right? You could have also done the moles of HCl is equal to 0.200 moles per minute times 10 minutes. 2.00 HCl. Does it make sense? So now that I have moles, I can take that and I can put it in my table. I can put it in my table because now it's not a rate, it's just moles, and then I could go and do the stoichiometry.
And then you get 100%.
And then you get the moles, and you can just go straight through the molar mass, 100.1 grams per mole, and you'll get 100.1 grams. And then you take that, minus it from 125, and it would have been left.
Oh, because you do have to do.
You do have to minus it because that's how much you had. This is how much you used up. That's how much was used up in the reaction.
Oh, okay.
So there's two things. The major one, I think, is from Chem 11, just knowing that you can't use stoic with grams. Like every time you do that, like just take a field hockey stick and like hit yourself or others and like make it really memorable.
Okay.
When they trained knights, they used to have a target that if you missed it, it would rotate and a large sack would knock you off and throw you in an icy cold pond.
Okay. Are there more questions like this? This
There-
is just part A.
Yeah, that's just a rate calculation. Yeah. And there are more in Hebden, and there's also a lot more. Have you used any of the old exams?
Yeah.
Do you do the long answer as well as the multiple choice?
I just think it's not
So,
I'll go to like, it's usually like question 7 where it stops.
yeah, no, this is something, I'm gonna do this to the whole class, because I found like, I mentioned it at the beginning,
Okay.
and then I found like the whole class, not the whole class, half the class last year was like, what? And so I had to show it a few times. A reminder, when you go onto the chemistry folder with old exams, And which one of these numbers is somebody's favorite number?
0006.
There we go.
PF.
No, I'm not doing the French version. There is a French key.
Do that one.
I'm gonna take out the key. And so, what numbers should you be able to do?
1, 2, 3, 4, 5, 6.
You should be able to do up to 6. And unfortunately, I've mentioned this before, but now that you're doing it, there's a key thing. You can do more questions than that. Which ones can you do? No, well, you might be able to do some of them, but where are the other questions? If you keep scrolling,
Oh, down into the.
there's the long answer. So you should also be able to do question 1. It's a C question, and maybe 2. It's B6, but it's got a little bit of equilibrium in there, so you may not be able to do it. And so, but you definitely should be able to do question 1. So don't forget the long answer. Definitely use them for practice. The answers to the long answers. Oh, look. So let's do that one. 0006. And we should be able to do right here. Which of the following reactions would be slowest? So 1, 2, 3, 4, 5, 6. And then, if you go to the long answer, complete the following steps in this. Ooh, I like that one. You know how we were summarizing it to make the overall? This one gives you the overall, and you have to recreate the steps. So undo the canceling based on what's there. That sounds like excellent practice. Would you like to practice that now? No, there's no general chorus of yeses.
Can you have them first and then do
You can do it, yes, but don't forget about the long answer. I found a few students that just never scrolled down and forgot they existed. They are useful to practice. Then they give you test quality versions, as in they're not intended to teach you anything. They're intended to figure out if you know it. And so they'll ask it often in weird and subtle ways. The Hebden is intended to get harder as you go later in questions on the same topic and scaffolds it. So if you find it gets too hard too quickly, because you're doing question 1, 3, and 7, then do 1, 2, 3, 4, 5, because you will go through all of the steps. Yes? Maybe. Oh, where is this taking place? Yeah. Well, this makes use of that CL reacts with an H2 and makes HCl, right? HCl clearly. What does H look like in terms of what we just done? In terms of, if I was to say, what's the overall reaction? What would H be classified as?
What do you look for, too?
An intermediate. What would CL be classified? Well, it gets made, and then it gets used up. So it's also an intermediate. So is HCl an intermediate? No, it isn't. It's not a trick question. The stuff on the side, products. It's a product. So once it makes HCl, the HCl stops. It's made HCl, but then that Cl goes and finds another H2 in the reaction. And then that H goes and finds so it keeps doing that, the more that each time it finds it, yeah. Yeah, it goes all used up. And that's why chlorine, in sunlight, eventually just breaks down into hydrochloric acid. Does that make sense? Yeah. So that is it's a weird example of a chain reaction. I don't know that you tests instead of me. Which one did you want to take? Oh, the one you're going to miss. Let me look at my schedule. Oh, and I don't. Mm-hmm.
Can you use my question?
Yes. 1 second. I just said I was going to.
And this one.
Oh, hold it. We end at 45. We're going to get to stop soon. We are
What'd you get?
Friday. Elena, you're not days. Excellent. I'm on Sunday duty.
My other one got marked wrong, so I did better on the last
I
one.
was Sunday afternoon, sir.
But this one not the one.
What time?
I never know exactly my schedule until Sunday. But I'm back in the house by the afternoon, like 2 o'clock and onwards, probably good. But before like 4. In fact, I'll probably be back in by noon. So between noon and 4, pick a time. Text me on the day to say you are in fact coming over, and I'll make sure there's a quiz for you. I'm gonna make it work.
Can I just take C?
Yeah, this is a version of what everybody else. I'll just make up. I just have to make up a new version. That's pretty cute,
Wait, is there
but that's okay.
Is there an option to do B and C? Or no?
I think it's like smarter if you don't do B and C.
Well, yeah.
Well, someone has asked that I do that, and so I told them to email me every day until I said I'm done.
But like if you like fail. No. I'm saying if you fail B and C or not the one down your
Failure is important.
No.
I can illustrate what failure is important.
No,
Right
but
now.
but it could bring down my B.
Yeah, but what really matters is how you do on the test.
Okay.
So finding out where you fail before the test is important.
Do you mark long answers different from short? Like say I mess up my long answer.
I don't consider a difference between long and short answer. It's just multiple choice and answers. -1 for chemical mistake, -0.5 for a mathematical mistake, which is the standard between myself, Mr. Snow, and Ms. Carroll, I believe. Also I have a key if I need to judge it. If it looks so completely wrong, I don't know what's going on, then what I do is I look for things you've done right and add marks. Because normally you're just looking for what mistakes have you made that you need feedback on and take off marks. So I change it depending on what kind of answer I get to whatever is the most fair in the moment. It's just a quiz. Yeah, you don't know. Yeah, could be either. B doesn't have that many long answers that I like, so,
Okay.
and I want to save some for the test. Oh, you had a question.
I just have one.
Oh, yeah. So,
Because
when they're approaching each other, what's happening to the potential energy?
wouldn't it decrease it? Because they're getting.
They're squishing into each other. What's happening to their speed?
Oh.
Oh,
Yes, the kinetics going up. What's happening to their potential?
decreasing. How would
No. They're squishing into each other. What's happening to their speed?
going up?
Come here.
Okay.
Stand over there. Run. Did you slow down or speed up when we hit?
Slow down.
You slowed down.
Yeah, but that's like when
They're
they
squishing
make contact.
together. But they don't have rocket engines. They're not going faster as they approach each other. They're traveling at a constant speed until they hit.
Okay.
When they hit, what happens to their
I know,
speed?
but it's not asking when they hit. It's asking when, like as they approach.
Right.
Yeah.
So as the electron clouds start to interact, what happens?
No, I thought potential energy would decrease, but kinetic is increasing.
Kinetic is decreasing.
How is kinetic decreasing?
If big things hit, they slow down.
I know, but it's asking before they hit.
No, it's not.
It is.
It's saying as they approach each other. So in the time before it stops. So let's start.
I thought the question was asking.
No. Here's the molecules touching. Okay? So that is they've touched. This is the molecules. 1 kilometer apart. They're traveling. Now they're getting faster as they move? No, they're just traveling. So what happens to potential energy?
No?
If they're traveling at constant speed and their bonds aren't changing, stay the same. So it's just stay the same, 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 stay the same. They start to interact when they're getting close to each other because they're not touching, but their electron clouds are touching. What happens to the potential? Do they speed up or slow down? Slow down. So what happens to potential energy?
But I thought like potential energy decreased as they got closer together.
Yeah, you're wrong. Approach. What's the opposite of approach? It's leave.
But I
That
thought,
seems-
yeah, but the more distance, the more potential energy.
Pardon?
I thought the more distance, the more potential energy. Like,
No. Because at a certain distance, it doesn't matter. It's just staying the same. It's just a long straight line. They're not reacting. They're not interacting. Nothing's happening. They can be miles apart. Same potential energy. Because potential energy is the energy in the bond. The only time that changes is if the bond is strained. Think of bonds as like, I don't know, a reverse elastic band. Think of them as springs. When you push them together, the energy goes up. And then when they go apart, they spring apart again. And then that goes faster. Bonds are springs. I know exactly why that is not an uncommon cognitive thing to do, but when they're far enough apart, they're not even interacting. So they're not really approaching each other. They're just far apart. It's only when they start to interact that we consider them approaching. And then the activated complex is when they're fully interlocked. And then they go like that. Okay?
I like that question.
Well, that's the reason for the quizzes, is so that you see those things, get that out of the way.
Can you also explain this one?
Which one of those is the mass going to change? Matter can neither be created nor destroyed, so none of them will the overall mass change. But which one will have mass escape? Gas.
I see.
That's
I was
Alka-Seltzer.
just thinking, yeah, that makes sense actually.
There.
Did you get this one right?
Which one?
The last one?
Yeah. I had to like read the whole question, right?
Yeah, I'll do all the cases up on the board.
I got 2 of 3.
Wait, can I see?
So, so this one, energy is coming out, released. So this is an exothermic reaction. So, yeah, so this one would look like this.
What? No, you should get one.
Whoop, I did that wrong.
Did you divide?
Wait. No, you just.
So the delta H goes down. So it would be negative.
No, 'cause
So
you
that
circle
that means
both
this
with
one
100,
is an
right?
exo. In fact, these
Right.
two reactions.
Multiply those.
Let's go I and IV.
Oh, yeah, you just.
Those two are exactly the same. This is how you write it with the term in it. That's how you write it with a delta
And then
H.
if you take the one.
That's endothermic because that puts it in here. You added it. And so that in this case, delta H went up. And one of those answers is a sneaky little jerk because they took this one and I think they rewrote it like this.
I didn't even get close. So.
Right? And that is still exothermic. They just mathematically did a minus sign there. Chemists don't like minus signs, so we put it on either side because you can't have negative energy. But technically speaking, yes, you minus 50, it works mathematically, it makes sense. So that's still an exothermic reaction. They just moved it around to see if they could catch anybody who were just looking for the term there.
We should do both.
Yeah?
Are you guys going skating with us on Saturday?
I don't think so.
Why are we not doing that then?
Well, no one's planned it.
Oh, it is hope skating.
It is, it's hope skating.
I thought it was with you guys.
I know we're going bowling after interhouse basketball.
Yeah.
That's on like.
No, there's no interhouse basketball. It moved in November.
Wait, actually?
Yeah.
What?
Why?
I don't know.
You sure?
Yeah.
'Cause
Yeah.
It's in November. I am playing. I'm gonna get so
Yeah.
concussed.
Okay.
Anything for inner house. I'm gonna have to do squash this year, so. Who plays squash?
How are you gonna get into custom basketball?
Peterson, I could hook it up. What?
How are you gonna get into custom basketball?
Because I would want my friend definitely want to jump at me. She's gonna punch me. Did she play that? No, she's played this year and she's
What are you doing, man? Privet's like pretty solid for interhouse basketball.
all they have to do is do this above the net. Your whole house is 8 foot.
Is Gabe in your house?
Yeah.
Gabe's kind of good.
Hmm?
Gabe's kind of good.
I don't know. He's like 50-50. Sometimes
Is
he's
he
like
good at
really good,
basketball?
and then sometimes he plays like.
Yeah, we can just
He
get
shoots like 0%.
run the ball up
I've
and then
never
get
seen
Timmy and all those other guys just blocking the net.
Just have him stand in front of the
Just
net.
have them stand
I'll
there, make a
run it.
wall.
I've never seen Gabe play basketball until Brentwood.
Yeah.
Mm.
Oh, you know him?
Yeah.
Oh. Oh yeah. Yeah. So we got.
He's had
I
that was
was.
pretty sick. I should say I live like a block away.
Really?
Yeah. I could get to his house from mine in like 100
Who
minutes.
do you guys have for basketball? You, Ben, and then that's it. Alex Rudolph.
Naomi.
But
You, Rudolph.
Rudolph, Timmy plays.
Jamie.
Jamie.
Timmy plays. Justin plays.
Rowan.
Alex
No.
Yeah.
Rowan will not be
Basketball.
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 She doesn't do any of the inner house
Bro,
things.
I was
Pro-
a
pro-
stack
like
for
basketball.
basketball.
Your stack
Who do they have?
too.
Julian?
Just literally
No,
put each other on each
no,
other's
but height
backs.
doesn't do like.
Okay.
Actually, like.
I will do
If you can get out your new notes, I think we've devolved. Last 10 minutes, we're going to start the next section. This is where I get to say, I'm hoping this occurs. I can email your house parent. If you could come to the next class in attire suitable for volleyball, it would be appreciated. We have a lab that I cannot do in the classroom now that we've switched classrooms because we might break the windows, whereas we didn't tear in the Ross, and we were surrounded by concrete walls. And when students did things, they didn't. Well, they might sometimes broke themselves, but the physical layout was fine.
Wait, next.
So Thursday's
Wait.
class,
Wait, so we don't have to wear number ones?
I'm going to ask that you come in attire suitable for volleyball. I will send out a new email on Wednesday because I have to confirm with. I have never set up volleyball before. I need a volleyball net.
You guys set it up.
There's like a bunch of people.
Do you know how to set it up in the gym?
Yeah.
Do you
And
have
do you have?
keys?
I need keys to get the. We need like 20 volleyballs.
That's too.
We're not playing volleyball. We're playing a version with 20 volleyballs.
Like this week?
Regardless, I think it's
This week, yeah.
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 So we can pull up
Wait,
to
next
assembly
class.
in
And yeah,
shorts.
yeah. I don't know what block is F block on that day.
When we get to
It'll
my
be
birthday,
EFD.
It'll be last.
It'll be last.
DEF.
Yeah. So now I will say, how many of you are on the stage during assembly? You
I can't
might
make
be
it.
expected to get changed after. I don't know. That would be up between you and the sponsor.
But like, there's so many rows of chairs that we can just hide ourselves behind the
That's
curtain.
good, that's
Wear
good.
your jersey.
But I will send an
You
email,
have to wear your jersey.
because I have to confirm with Mr. Langer, I can get keys. Or at least get keys for the gym,
Definitely can.
because
get them
that's
Wednesday.
weird. Okay,
Yeah.
so ignore this, because this
Friday.
is the first step that is part of the actual, is it this one? Yeah, we want this one, and then we're going to do a little thing, but I can't do it right now because if I pile the desks up in here and we start throwing paper or balls back and forth, I think I will get shot. We are going to start with equilibrium. Equilibrium is defined,
Wait, where is this?
is like way ahead.
Why do we not start at the start?
Because that's Thursday.
How far ahead?
Page 8 to 9.
8 or 9?
Well, 9. There's 8.
Yeah, there you go. And this doesn't look fancy enough. Sorry. So what I've done here, this is the top half of an arrow going this way. And then I draw the bottom half of an arrow going that way. Because we have been doing reactions like they go like this. And then we just stay here forever. But we know that reactions can go like this. And you know that too. Because can you take rust and turn it into steel? Yeah, obviously reactions can go backwards. Some reactions go forwards and backwards at the same time. In fact, you could probably get away with saying that all reactions do that. It's just some of them, their forward rate or their reverse rate is so fast that it basically doesn't. We're going to learn how to figure out which ones do, which ones don't. There's two forces in the universe, and so far you've only learned about one of them. The one that you've learned about is called enthalpy, and that's delta H. And you know if it's exothermic, it's probably likely to be spontaneous and go forward. But there's a whole nother force that's involved. And if they impose, then you can get reactions going both ways. And they go both ways in a way that is constant. So you can't really tell the difference. Given that we have 4 minutes, we will demonstrate it by holding hands in a circle. Everybody stand. You're not actually going to hold hands in a circle, but tuck in your chairs and form a ring around the classroom. So on the outer edges. I'm going to draw a line right down the middle, like this. Everything on this side is a reactant and wants to come this way. This is your reaction path. You can only go this way. Everything on this side is a product. You've been made from a reactant. However, there's a secret back door that you can also go and become a reactant. And you do so by going through that reaction pathway. Start going through your reaction path. But you can't stop. Excellent. Excellent. I feel so powerful. Stop. But you kept walking.
Oh,
1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6, 7. Okay, keep going.
It's like musical chairs.
Stop. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. If, to an outside observer, we were only looking at the number of particles on both sides of the reaction, would we ever notice a change? How many particles are on that side? 7 or 6. How many are on that side? 7 or 6. It's going to be the same. And yet, when I say go, you go. You are moving the whole time even though nothing is changing. I just get to make you walk for my pleasure and see people just doing work for no reason. Now, you can have a seat because it's the second part of the demo. Now, if I was to cut it in half here, I'd have 1, 2, 3, 4, 5. And here, 1, 2, 3, 4, 5, 6, 7, 8. But if I cut it here, and someone was just looking for, on a monitor somewhere that just measures the amount of students on either side of the classroom because they're, I don't know, doing some unholy experiment, would they ever see a change? Like you just sat there, shackled to your desks forever? This is known as a static equilibrium. It's static because you're not moving. When you were moving around, that was known as a dynamic equilibrium. Because although things don't look like they're changing, there's actually a lot of motion going on and people are moving all the time. It's just that there's something that's the same. What was the same on both sides of the reaction? I could measure energy, right? It is a type of energy. What kind of energy do you have running around the classroom? Kinetic energy. So what kind of energy would I be measuring here? Pardon?
Like right now?
Yeah, like if you were walking, what could I measure here to know? Pardon? Yeah, give me a type of kinetic energy that I could measure. How would I measure the kinetic energy right here? If I wanted to measure students. People passing per minute would work. Before you go, what would be the people passing per minute here and there? It would be the same. That is dynamic equilibrium. Thank you very much. Go enjoy your last class. What is your last class? So that is the best kind.